Since the beginning of human history, we are fascinated by that big, shiny, round thing in the night sky. That is the moon. It seems round. But not really, is it? Which you already knew, sheesh. In 2008, India launched a mission to moon called Chandrayaan, meaning moon vehicle. It was the first mission where an Indian spacecraft had to go beyond the protective cover of the Earth's magnetic field. India researched and developed its own technology in order to explore the moon. The vehicle was inserted into lunar orbit on 8th of November 2008, costing around $56 million. A PSLV-XL was used in this mission because the mass of Chandrayaan-1 was 1,380 kilograms. It is a 4-stage rocket with alternating solid and liquid engines. It took 5 days to reach the moon's orbit after leaving the Earth's orbit. This is how the gravity of the Earth was used to slingshot the spacecraft towards moon, thus saving fuel and reducing cost. Apart from 5 Indian instruments, 6 instruments from other countries were sent, including 3 payloads from Europe and 2 from USA. Discovery of water ice. The impact probe separated from Chandrayaan at 100 kilometers from lunar surface and began its nosedive going into free fall for 30 minutes. As it fell, it kept sending information back to the mother satellite, which, in turn, beamed the information back to Earth. The altimeter then also began recording measurements to prepare for a rover to land on the lunar surface during the next moon mission, that is, Chandrayaan-2. Well, that is smart. This is where it impacted. Do you see the blue part? It's water ice. There were many objectives that were achieved during the mission, yet finding water ice was the most popular one. During its operational period of 312 days, it completed over 3,000 orbits, sent over 70,000 images back to Earth, which was received by Deep Space Transmission Center in Bengaluru, India. Yup, 70,000. Geez. However, around 1:30 IST on the 28th of August 2009, communication with the spacecraft was suddenly lost, probably due to intense fluctuations of solar radiation. Oh oof. Even then, it completed over 95% of its objectives. Not high enough, by Indian parents' standards. LOL. Okay, now Chandrayaan-2. It is expected to be launched in July 2019 on a GSLV-Mk3, which can carry the spacecraft over 3,877 kilograms to lunar transfer orbit. The mission will carry 3 parts: 1. The orbiter, 2. The lander Vikram, 3. The rover Pragyan. See some pictures too. Do you see? Okay. Whoa. ISRO selected 5 scientific instruments for the orbiter, 4 for the lander, and 2 for the rover. All the scientific payloads are Indian. Also, one NASA's laser retroreflector was added to lander's payload to help scientists measure exact distances to the moon. What will orbiter do? It will carry on imaging of moon's surface in various spans like X-ray spectrum, infrared spectrum, 3D photography, etc. It will also help lander and rover to send data back to Mother Earth. What will lander and rover do? They will perform experiments on moon soil to detect composition and thermal properties using laser and alpha particle-induced X-ray spectroscope. They will also detect seismic activities and plant a retroreflector on the moon's surface. Chandrayaan-2 will attempt to soft land a lander and rover in a high plane between 2 craters, Manzinus C and Simpelius N, at a latitude of about 70 degrees south. If successful, it will be the first mission to land a rover near the lunar South Pole. Recently, about a month back, Israel tried to soft land on the moon with its Bear Sheet mission, but the lander malfunctioned and it crashed on the moon. So, let's hope The mission is a success and India becomes the fourth country to soft land on the moon's surface and first one to land near the South Pole. If this wasn't boring enough, wait more. Just kidding. Subscribe if you like this stuff. Bye bye. I'll go now. Hey, are you still here? This is beautiful, isn't it?